In this section, we're going to be factoring by greatest common factor. So let's start with an example of factoring a polynomial. So here we have 4x squared minus 3x. So we're going to try and break down each term first. So let's start with the 4x squared. When we break down the 4x squared, we want to first break down the 4, so we know that it can be broken down to two prime numbers, 2 times 2. And then the x squared can be broken down to x times x. Now, let's look at the 3x. The 3x can be broken down into 3 times x. So we got to find the common factors between this, and we can see that they both contain at least one x. And between the numbers, there's no commonality, so the greatest common factor of 4x squared and 3x would be x. So that's the only thing we can pull out of the polynomial. So you want to write x, then make a parentheses. Now, if we took away an x from 4x squared, we would only be left with 4x. If we took an x away from 3x squared, we would only be left with a 3. Now, if we were to re-multiply the x back in, you would see that that would be the top equation. Now we're going to look at another example of this concept. We have 5x squared plus 7. So first, let's start by breaking down the 5x squared. We can break the 5x squared down into 5, and the x squared down into times x times x. Now let's look at 7. 7 cannot be factored any further because it is a prime number. So as we can see, there are no common factors between the two, so this polynomial cannot be factored. Now we're going to look at factoring out a common binomial factor. So we have the problem 7 parentheses x minus 3 minus 2x parentheses x minus 3. When we look at this equation, we can see that we have a common binomial factor of x minus 3. The binomial in red is going to be the common factor. So what we can do is we can factor out the x minus 3. So let's write x minus 3 first. And if we were to pull an x minus 3 away from the 7 times x minus 3, we would only be left with a 7. So the number in the green. And if we were to pull away the x minus 3 from the 2x times x minus 3, we would only be left with a negative 2x. So our binomial can be factored down to x minus 3 and 7 minus 2x. Now we're going to look at an example of factoring by grouping. So we have the problem 12a cubed minus 9a squared plus 20a minus 15. So we want to group terms that have a common number or variable as a factor. And we can see that 12a cubed and 9a squared have the highest degrees on their a variable, so we're going to group them together, and we're going to group the 20a minus 15 together. So we want to attack each group separately. So let's start with the 12a cubed minus 9a. We can see that they both have a common factor of at least 2 a's. So let's pull a2 out, a squared. And then between the 12 and the 9, we can see that 3 can divide into both 12 and 9, so we're going to pull out a 3. Now, if we were to pull out a 3a squared from 12a cubed, we would basically be left with 4a. And if we were to pull out a 3a squared from negative 9a squared, we would be left with 3. So basically, you can divide the number inside by the 3, and then subtract away the number of a's that were taken out. Now we're going to look at this next set. A common factor between 20 and 15 would be 5. That's the greatest common factor. So we can pull out a 5, but only the 20 has an a, so we cannot pull out an a. Now, if we pull out a 5 from 20a, we would be left with, the answer would be 20 divided by 5, which is 4a, and then 15 divided by 5, which is 3. So our common factor now, as we can see, we have 4a minus 3 in both of the binomials. So we want to factor it out. So we have 4a minus 3. Now if we were to take away a 4a minus 3 from 3a squared times 4a minus 3, we would only be left with a 3a squared. And if we were to do the same thing with the 5 times 4a minus 3, we would only be left with a plus 5. So this would be our final factorization. Now we're going to look at an example with factoring with opposites. We have to factor the problem 3x cubed minus 15x squared plus 2 minus 2x. So first we want to start by grouping the terms. So let's group the first two terms together because they have the highest degree. And then we're going to group the second two terms together. So 10 minus 2x. Now what we want to do is we want to factor out the greatest common factor of each group. So if we look at the first group, 3 would be the greatest common factor because that's the greatest number that can be divided into both of those. So we pull out a 3, and we can see that they both have x's, but the 15 only has an x squared, so we can only pull out 2 x's. Now if we were to divide 3 by 3, we would get 1, and if we were to subtract x cubed from x squared, we would be left with x. So now let's look at the next part. If we were to divide 15 by 3, we would get 5. And then because we pulled out an x squared, there is no more x on the 5. So now let's find the greatest common factor of the second group. 2 would be the greatest common factor because 2 is the greatest number that can be divided by into both of the terms. And 10 divided by 2 would be 5. And then negative 2x divided by 2 would leave us with a negative x. We can see that x minus 5 and 5 minus x are not exactly the same because one of them is flipped. In order to fix this problem, we can pull out the negative from the second grouping. If we pull out a negative, we're basically pulling out a negative 1, which would then make the x positive and the 5 negative. It's kind of like distributing the negative 1 out to the two terms. Now that we've done that, we can simplify a little further. We get 3x squared times x minus 5 minus 2 times x minus 5. Now we can see that we have an x minus 5 and x minus 5 as a common factor. So we can pull that out. So put parentheses x minus 5. And if we pull out an x minus 5 in the first set of 3x squared times x minus 5, we would only be left with a 3x squared. And if we pulled out an x minus 5 in the second set, we would only be left with a negative 2.